Hey, this video is going to go over the activity titled, Will Mrs. Gallus Prove Herself? Now, before you guys start on this activity, here are the learning targets, the success criteria for the activity. So number one, we want to interpret the power of a significance test. So yes, that's a new term. And then criteria number two, we want to describe what factors will affect the power of the test. All right, so for this activity, each group is going to need one laptop. You'll be using a website to answer some of the questions in the activity. You see here there's about 4 questions on the front page. Let's go ahead and budget about 15 minutes to work in groups on page 1. If somebody doesn't mind setting the timer on the sideboard, and then pause the video during those 15 minutes. When you're done working, you can unpause the video to hear the debrief. All right, so let's go ahead and debrief this activity. Now here are some kind of student solutions, some student responses to the questions. Question number 1 is just kind of a refresh, a revisit to the hypotheses. We came up with the hypotheses way back in the very first activity, so all you needed to do was kind of copy them from that activity. Question number 2, we're looking at a type 2 error. So we learned about type 1 and type 2 errors in the last activity. So a type 2 error occurs when the alternative is true and we fail to reject the null hypothesis, right? So in this case, the alternative would be that Mrs. Gallus is a less than 80% shooter, and failing to reject the null hypothesis means we didn't find evidence that she is a less than 80% shooter. Okay. All right, now the rest of the questions in the activity require you to use the applet, the online website, to investigate error probabilities, but also probabilities of making some of those correct decisions, which that's referred to as the power of the test. Okay. So first thing I want to highlight here is that calculating the power of the test is not something that is easily done. In fact, to find the power of the test, you must have a specific value for the alternative hypothesis. Okay. So in question 3, that value was 66%. Okay. So make a note here. For calculating power, okay, there must be a specific value for the alternative. And so here we're going to label the alternative hypothesis as her true proportion being only 66%, okay, which falls in line with the original alternative being less than 80%, but now we're picking a specific value that's less than 80%. All right, let's describe what's going on with these two distributions here. All right, so there's the blue one on the left and the red one on the right. Okay. So first, the red distribution, or the one on the right, represents the situation when the null hypothesis is true. Okay. In other words, this distribution is what we would expect if Mrs. Gallus was really an 80% free throw shooter. Right. Most of the samples we observe would give a result in the neighborhood of 80%, but because of variation, sometimes we might get a result that's kind of on the low side, and sometimes we'd get a result that's on the high side. The distribution on the left, the blue one, represents the situation where the alternative hypothesis is true, meaning that Mrs. Gallus is really only a 66% shooter. Right, and it's this distribution that we're going to focus on. So this shaded region here in the left tail, right, this represents the type 2 error. Okay, so we can label this type 2 error. Okay. On the website, you found that to be about 24%. Okay. The unshaded region in this distribution, which makes up the majority of the curve, okay, all of this region here represents the probability that we make the correct decision, right? That we conclude that she's a less than 80% shooter because in reality she was a less than 80% shooter. We call this the power of the test, right? It's the ability to reject the null when the null should be rejected, right? Or it's the ability to find evidence for the alternative when the alternative is what's true all along. All right, so the two probabilities here, the 0.24 and the 0.76, right? Each of these represents a different outcome, right? So the 0.24, that's our type 2 error. Or it's the probability of making a type 2 error. And then the 0.76 represents the power of the test. Okay, the likelihood that we reject the null when the null should be rejected. All right. Now, interesting thing about these two probabilities is that they are complementary of each other. Or if you add them together, it equals 1. Right? And that makes sense because they represent the two different regions of the same distribution. Right? So the unshaded region plus the shaded region equals the total area, and the total area is 1. Okay. So let's write this down. The probability of a type 2 error plus the power of the test equals 1. Complementary outcomes. All right. The next question is an interpretation question. So we want to describe what this probability means in context. Okay. So first of all, it has to do with the alternative being true and us making the correct decision. Okay. So in context, that means Mrs. Gallus is really a 66% free throw shooter. Right? That's what it means for the alternative to be true. And there's a 0.76 probability, right, or a pretty high likelihood that we find convincing evidence that she is a less than 80% free throw shooter. So we find evidence for the alternative hypothesis. All right. The last question wanted us to investigate ways that we can increase the power of the test, right? Ways that we can increase the likelihood of making this correct decision. So I'm going to switch over to the app here for a sec so that we can all kind of see it together in real time. Let's reload it. All right, looks like I have to reset it now. So the null value was 80%. The alternative hypothesis is that she's a less than 80% shooter. We'll look at the type 2 error when her true free throw percentage is 66%. Okay, sample size was 50, significance level was 5%. All right, so you can see here, right, that the likelihood of her making a type 2 error is 24%, and that's the shaded region here. Okay. The power, which is now this green region, right, represents the probability of making that correct decision. Okay. Now we want to look at, and here's the power initially, 76%. All right, so how can we increase the power? How can we raise that percentage there? Okay. Well, if we increase her true shooting percentage, okay, that actually made the power worse. Okay. If we lower her true percentage, okay, that made the power go up. Okay. So if she's a lot worse than what she's claiming, right? She's claiming 80%, but let's say she's really worse, right? It's going to be easy for us to detect that, right? I like to think of it this way, right? It's easy to catch somebody telling a big lie than it is to catch them telling a small lie. Okay. Let's look at the sample size. So if we increase the sample size, what happens to the power? Oh, look, it went up. Okay. And that should make intuitive sense, right? The greater the sample size, the more information we've gathered. And we should be able to make better decisions with more information. And it's harder to make good decisions when we have less information. Okay. So more information should lead to better decision making. All right, let's reset that back to 50. And then the last thing we're going to do is we're going to look at what happens when we change the significance level, alpha. All right, so let's see what happens if we increase alpha. Okay, and you can see the power went up to 85%. Okay. So if you think of it this way, increasing the significance level just makes it easier to reject the null hypothesis. And rejecting the null hypothesis is required if you want to make the right decision. Right? If you want to, rejecting the null hypothesis is required if your goal is to correctly find evidence for the alternative. Right? Okay. So we either increase the sample size, increase the significance level, or decreased the alternative value. Okay. All of those led to more power. Okay. All right, so let's write some reasoning for each. Okay. So increasing the sample size, I don't know if you caught this, right? Look at the variability of the distributions when we go from 50 to say 200, right? They get a lot narrower, right? So the variability decreases, and now there's less overlap here in their tails. All right, so increasing the sample size will lower the variability of both distributions. Okay, and that in turn decreases the overlap. Okay, and the overlap is where we found the type 2 error. Okay, so if we can decrease the overlap, we can decrease the risk of a type 2 error, which has the kind of added bonus of increasing the power of the test, right? Because they both have to add up to 1. If type 2 error goes down, then the power has to go up. All right. Again, I like to think of it this way. If you increase the sample size, you gather more data, and with more data, you should be able to make a better decision. Okay. All right. Increasing alpha, or the significance level, makes it easier to reject the null hypothesis. And rejecting the null hypothesis is required for the power. All right, the last one was decreasing the alternative value. Okay. Now, really, I talked about being able to detect a big lie versus a small lie. Right, so if we reset, goodness, got to reload it now. Okay, 80% less type 2 error, power 66. Okay, so if she claims she's an 80% shooter, but maybe she's like a 75% shooter, that's a really small lie. It's hard to catch people telling small lies. Okay, but if she's claiming to be 80% and she's really 16%, that's a big lie, and we should be able to detect big lies pretty easily. Right? Okay. Yeah. So it's not the fact that the alternative value was lower, it's the fact that it's farther away from the null value, right? The bigger the gap between the null value and the alternative value, right, the wider that gap, the easier it will be to make the correct decision. Okay, so our power will increase. Okay. All right, so if we increase the distance from the null value, okay, between the null value and the alternative value. All right, let's summarize on page 2. Okay. So here was the kind of Punnett square table that we had that summarized the 4 different outcomes. So we already know that there's, the type 1 error and the type 2 error. Now here's where we were focusing today, right? What's the likelihood that we can reject the null hypothesis when some alternative value is true, right? And that's a correct decision, but now we're going to give it a name, and we're going to call it the power of the test. All right, now the 2 errors, each one has a different risk or likelihood of occurring. The type 1 error is, the likelihood of that is just the significance level, so usually 5%. Okay. And then the probability of the type 2 error, okay, remember that it's the complement of the power. Okay. So its probability will be 1 minus the power of the test. All right, let's formally define the power of the test. Okay. So the power is the probability that we reject the null hypothesis given that some alternative value is really true. And then here's a template that you can use to interpret power. So if the alternative is true and you need to specify a particular value, right? So for instance, if Mrs. Gallus is really only a 66% shooter, okay, then there is a power probability of finding convincing evidence to reject the null. All right, I think the power on page 1 was 0.76. Okay, so we could say, right, if Mrs. Gallus is only a 66% shooter, there's a 0.76 probability of finding evidence to reject the null hypothesis, meaning to reject the claim that she's an 80% shooter. All right, there's 3 ways that we can increase the power of the test. Okay. Number 1, we could increase the sample size. Okay. More data means better decision making. Okay. Number 2, we can increase the significance level. Okay. That just makes it easier for us to reject the null hypothesis. And remember, rejecting the null hypothesis is part of the definition of the power. Okay. And then thirdly, we could increase the distance between the null value and the alternative value. Okay. And remember here, just think about this, right? It's easy to detect a big lie than it is to detect a small lie. All right, so I'm going to have you pause the video one more time and maybe set the timer to 10 minutes, okay? So give yourself and your table 10 minutes to work through the check your understanding question, okay? When the timer runs out, go ahead and unpause the video, and then you can check answers. I'll have the answer key posted in the video. All right, so let's go ahead and debrief and check the answers here. All right, question part A. Okay, so the interpretation of the power. Okay, so if 70% of guests will really be attending the party, there's a 0.10 probability that we'd find convincing evidence to reject the null, and that is that 75% of guests will attend. Okay. All right, part B. The probability of a type 1 error is our significance level, so that's 5%, and it's right there. Okay. The probability of a type 2 error, that's 1 minus the power. Okay, so 1 minus 0.10 leaves us with 0.90. All right, part C. Okay, what will these things do to the power? So if we go to 0.01 instead of 0.05, okay, so we're lowering the significance level. Okay, that's actually going to make it harder for us to reject the null hypothesis. Okay, if it's harder to reject the null, right, you're going to decrease the power. Okay, you need to reject the null hypothesis to have power. Okay. All right, increasing the sample size to 100 instead of 25. Okay, well, think about it, right? More data means better decision making. So now you should have more power because you've got more information, right? Information is power. Okay. All right, so that increases the power. You could also argue that the variability decreases, so now there's less overlap between the distributions. Okay. All right, so this video is over. I think I'll have another video for your guest teacher to play for you, which will go over summarizing the 2 new procedures from this unit. All right, so bye for now, and I'll see you in the next video.